Okay, so now let's talk about vector cross product, right? So this is the final thing to learn about vectors. There isn't really that much other than this. So this will sort of complete your study on the mathematics of arrows. And this is the last thing to do is how do you multiply vectors? And we have two ways to do that. There is the scalar dot product. And that's when you write it as a dot. And the hint is in the name, right? The result returns a scalar. Whereas when you do this, it will return you something that is a vector. Okay, so sometimes we just call it a vector product or a cross product from the symbol. All right, just to remind you, with a scalar, if A and B are scalars, this all mean the same thing, or this. Okay, but for vectors, this means a scalar product. This means a vector product or a dot product and cross product. This means nothing. This means nothing. Never write that. If you write that, no one knows, do you mean this or this? All right. Or it means something very advanced in really pure math. If you ask a pure math PhD student, they'll tell you that's called an outer product or a bivector. But that's way beyond a class, right? So even for engineers, probably they rarely care about that. So make sure when you never just for 99% of the purpose, never just put two vectors next to each other. There's no meaning in most of for all we concern, right? It's unclear which one you mean. Okay, so we know we motivated this is basically how much is A contributing to B, all right? This number, the result that comes out of this, right, it's going to be just a number. It's not even going to be a vector. This number tells me sort of the intuition is how much A contributes to B. Okay, so if A is perpendicular to B, then it's 0 because A is not going to affect B. A's motion is not going to affect B's motion at all. All right. So we learned that there's two ways to solve this. You can do it the geometric way, which means if you know the magnitude and direction, this basically the answer, right, is going to be AB cosine theta included, right? It's the included angle between that times the magnitude of A times the magnitude of B, and an algebraic way, which is just take the components, multiply them together, and add them, right? So it's AX times BX plus AY times BY, like this, okay? Yeah, you can fill in the blanks. AX, BX, BY, like that. All right, so here, this time, this is the scalar product, right? And this is let's call it a dot product. And this is the cross product. And this will return you a vector, okay? I really want to emphasize it returns a vector. And now there is similarly a geometric way to do it and an algebraic way. You see it's very similar, okay? But I want to be very careful is the result of this. So the geometric way which gives you a vector, the magnitude of the results, okay, should I call it C or should I call it V? Let's call it C, right? So V sort of tells you it's a vector, but I'm purposely choosing something that potentially it's not obvious it's a vector, but I want you to think about it as a vector, to train yourself to see that whenever you see this combination, this is a vector, this is a scalar. Even though these two are vector individually, this is a scalar, okay? This is completely, individual things does not mean the whole thing is the same thing, all right? So this is a vector, this is a vector. When you dot product them together, notice I didn't say multiply because I knew it would be clear. When you dot product them together, they could be a scalar, okay? It's just like a negative number times a negative number could be a positive number. So individually they're negative, but together, when you look at this, your eyes, your brain should not say negative number. When you look at this together, your brain should go like, oh, that's positive, all right? So that's what I want to train you to see is, oh, if I see a dot here, that's just a scalar, all right? Immediately in your head, that's just a scalar. When you see a cross here, your head would say it's a it's a vector. All right, this result is going to be a vector. Okay, so yeah, so now it raises a question, right? Well, this guy, if this is a vector, it should have a magnitude and a direction. Okay, so what would it be? Now, the cross product, I'm not going to justify why, but I'm just going to tell you what it does. What it does is when you take two vectors, let's say A and B, make sure when you do these operations, have them start at the same point for reasons you'll see in a second. And even when we do addition and subtraction, even though it doesn't really matter that they start at the same point, I already mentioned that. So bring them to the same starting point first before you do any operations on them, okay? So put them at the same point. Now, when you do a cross product, it will produce a new vector. So it will be completely fair for you to ask me the question, right? Okay, it produces a new vector, A cross B, produces a new vector C. Well, what is the direction? What's the magnitude? Okay, and I'll tell you both. The magnitude is, it will come out, right? Geometrically, I need the magnitude and the direction. So the magnitude of C is going to be AB sine theta, all right? I'm gonna give you a slight justification later, but not really. But yeah, so I'm stating that as fact. Now, just to emphasize this as well, I will I will just draw it without this, but I want to warn you, and purposefully, you might say, well, if there is a chance to clarify this is a magnitude, wouldn't it be now? But we often don't really, don't write the clumsy notation, and we write the shorthand one. And I need to train you to be able to know that this is the magnitude of C, all right? I've seen plenty of mistakes of people writing this, okay? Whenever a student writes this, this line immediately gives you 0 because in terms of exam, because this is not meaningful. This is saying something that has components. It's something, a vector cannot equal a scalar. They are different things. You're saying something that has components, it's like saying 3, 4 equals to 5, this does not make sense. You cannot have 2 components equals to 1 component, okay? You can have this, right? Like that, you can do that, but you cannot have just 1 number equals to 2 numbers or 3 numbers, right? So be very aware of never write things like this, nor, which brings me to the point of, so put a footnote somewhere in your notes, right? Don't write this. Because now that I've mentioned it, I've trained you to think that, oh, that's a vector. That means vector cannot equal scalar. If you insist on writing something like this, well, also don't write this, because that means the magnitude of A times the magnitude of B, because if these are scalars, this just means normal multiplication. And where would the sine theta comes from? Because now you will cancel this, and then you'll have, oh, theta equals to 90 degrees. That's not that's not what's going on, right? You're talking about A cross B produces a new vector for which it's the new vector's magnitude is that. So you either write it this way or write it this way. So let me summarize it. That's okay. That's okay. That's okay. Given that A cross B equals to C, right? So assuming that C is defined somewhere. So this is okay. What's not okay is this is not okay. And this is not okay. So never have scalars equals to vectors, right? So just make a note on the notations. Okay, all right, so that's the rule. How about direction? Where does the C vector point? Okay, now that I know the length, and the rule is this, when you do A cross B, it will produce a new vector that is perpendicular to both of these old vectors. Okay, so this one's pointing here, this one's pointing here, they might be 60 degrees apart. Oh, theta is the included angle, by the way. Yeah, as usual. I'll label that. The C will point perpendicular to both A and B. So in this case, if both lie on the board, C will point out of the board like this. Okay. Now you might ask, actually I have 2 choices, either out of the board or into the board, right? Both of them is perpendicular, right? So let's just make sure we understand this, right? If C is pointing out of the board, it's really hard to draw out of the board. So we have the notation, a dot, when we draw like that, that means out of the page or the board or the screen in your case. And a cross means into the page, board, screen, slash anything that you're watching this on. Yeah, so how do I remember this? Think of it as like an arrow, like the ones that you shoot, or so I've heard. If you look at it from the front, well, don't put your eye in front of the arrow, but if you look at it from the front, you see a dot first, right? That's so a dot means sort of, it's like an arrow coming out of the board. And if you look at it from the back, you sort of see the cross first. So you see the feathers and you see the cross. So when you see the cross, it's like an arrow going into the page. And when you see a dot, it's out of the page. So that's a good mnemonic to remember. This is another comment on notations. Okay, so I'm going to draw C as a dot like this. Okay, so C is a vector that's coming out of the page. What's the magnitude of C? Magnitude of A times magnitude of B times cosine theta. All right, so that's the rule. All right, so unfortunately, this is not a math class. I can't go in depth of explaining why that's a good rule or where does the rule come from. But we'll keep it simple. Just remember magnitude, direction, and that's it, right? Now, so let's understand why this is 90 degrees to both. So you can see why this is 90 degrees to A. You can also see this is 90 degrees to B, right? A and B does not necessarily need to be 90 degrees. Okay, it's just whenever you have two vectors, they will always, as long as they don't overlap each other, they always make a plane, right? You agree? If you have two vectors, they'll always make a plane. And that means you can always find a third vector that will be perpendicular to the plane, which means it will be perpendicular to both of these, all right? The last thing to say is there's still two choices. It can either be out of the page or into the page. How do I know this is out of the page? Well, we just need to decide on a convention. Which one multiply which one, all right? So if A cross B, it will, if I do A cross B, so this is how you want to visualize it. A cross B will give you out of the page. And if I do B cross A, it'll go if you're into the page. And how do I remember that? It's called the right-hand rule. Again, use the right-hand rule. That will tell you the direction. So what is the right-hand rule for cross products? Rule for cross products, I should say. Right. The right-hand rule for cross products is you put your hand first, pointing your four fingers, pointing along A and wrap them around B. The thumb is going to give you the result. All right. So try to wrap your hand from A to B. So if you're asked A cross B, that's wrapping your hand from A to B. Okay. And you see your thumb right hand, and your thumb will point out of the page. Okay, so this will give you a C that is out of the page. Now, if you do B cross A, right? So this time you want to wrap your right hand from B to A, right? So the result is either your thumb pointing out or in, okay? So now if your thumb's pointing out and you try to wrap your hand from B to A, you will probably break your hand. So don't do that. I'm not responsible for any damages you make to yourself. So what if you stick your thumb into the page first, right? Into the board like this. Now it's very easy to wrap from B to A like this. So that's why sometimes people would draw an arrow like this from B to A. And so if you do B cross A, it will produce a vector that the resultant vector, it's called C prime. B cross A will create a vector that's into the page. Okay, all right. How about the magnitude? The magnitude is the same. A cross B's magnitude is AB sine theta. B cross A's magnitude is BA sine theta, which is obviously the same as AB sine theta, right? So notice one thing, right? This is one of the first times you probably will see something when you do A cross B, it's like times, right? It's like A times B is different from B times A. Right? This does not happen with scalars, only with vectors, and only with cross products, because dot products A dot B and B dot A is the same. But cross products here, I'll write this in red. I use this part of the board now. Okay, A cross B is not the same as B cross A. In fact, more precisely, A cross B is just negative of B cross A. Okay, so this does not happen with scalars, right? Because 2 times 3 is the same as 3 times 2. 2 times 3 is not negative 3 times 2. But for vector cross product, this is the case. Why? I think it's obvious. A cross B, you point out. What is B cross A? You point in, right? So it's just the opposite direction with the same magnitude, right? What I can do is, right, I can do a magnitude applied, look at a magnitude on both sides. You can kind of see how this works. Excuse me, this is the negative does not, the absolute value kind of negates the negative. So you just have B cross A. So what's A cross B? The rule is AB sine theta. So here you follow the rule, which will be BA sine theta. But of course, now you have a scalar multiplication over here. So you see that this is equal. So the magnitudes are equal, but the direction is opposite. All right. So magnitude, direction. Okay. So that's the geometric way of determining the cross product of two vectors. All right. Now, you don't always want to draw diagrams and you want to do it the algebraic way. This is the place where it is potentially a little bit more complicated than it sounds, and it follows a rule like this. And I'll first state the rule, and I'll show you the trick of how to remember that rule. All right. So when you do A cross B, so when we do algebra, let's do in full 3 dimensions. You have A1, instead of X, Y, Z, let's call it 1, 2, 3. It's just slightly easier to write. B1, B2, B3, like this. Does the textbook use 1, 2, 3 or ABC, X, Y, Z? Let's see. They use X, Y, Z, but all right, yeah. So you can see both perspectives, and you can decide which one is easier. All right. So remember, it produces. Does it produce a scalar or a vector? It produces a vector, right? So you will produce a result like this. Now the question is, right? So this would be C, right? This will be called C. Well, what's going on over here, right? With dot product, just for you to contrast A1, A2, A3 dot B1, B2, B3 is just A1, B1. So multiply this to B2 and multiplies this and just add them together like that. Okay, so that's for dot product. How about cross product? It follows a very annoying rule, but then I'll show you a trick to remember it. So I'll state the rule first is A2, B3 minus A3, B2 as the first component of C. So this is, it's got C1, C2, C3, right? Okay, so C1 is that. C2 is A3, B1 minus A1, B3. And C3 is A1, B2 minus A2, B1. Okay, I know what you're thinking. How on earth do I remember that? And this is how, let me just make a couple of observations first and tidy up my writing and make it a little bit larger so you can actually see it. All right, let me make a couple of observations before I tell you the trick. So one, C1, notice over here, this is all 2, 3, right? And there's no 1 in here. The second component of C only depends on the third and first component of A and B. There's no second component. And the third component of the result only depends on the first and second components of the original. All right. So whatever the component, the row of this is, the component of this is, it only depends on the other 2 components. All right. Now, because this is minus, the rule is minus, so you have to be careful which one subtract which one. And this is where you need to read 1, 2, 3 in a cycle, right? So sort of go around in a cycle like this. So 1, 2, 3, 1 like this. Okay, so what do I mean is C1 is 1, 2, 3. Okay, and then 2 is 2, 3, 1. So C2 goes from 2 and then 3, 1. And then C3 is 3, 1, 2. So 3, 1, 2 like this. Okay, and you subtract the other version of it. All right, so I know what you're thinking. This is horrible, right, to remember. However, there's a nice trick. All right, so here's the trick: is to use what's called a determinant. Okay, so if you know what a matrix determinant is, good for you. You're going places. If you don't worry. I'm going to show you, right? So the strategy is this. So if you're given the vector to cross product, you first take. Okay, so let me copy that again. 1, 2, 3. You write 2 lines like this, and that means determinant. Then you write ijk, and now take the first vector and put it horizontally over here. By the way, that's why I'm using 1, 2, 3 instead of x, y, z. It's sort of the cyclic property works better. But if you like, this also works. So x, y gives you z, y, z gives you x, z, x gives you y, something like that. Right? But yeah, anyway, back to here. Take that, put it horizontally, take this, put it horizontally. All right. So I'm sure everyone can do this step, right? Piece of cake, right? The next part is the tricky part. Is this. So at the end, you will produce something with ijk, right? Right. So what is the ith component? What is the jth component? And what is the k component, right? That's the question. J component and something k component, right? So the trick is this. When you solve for the I component, take your hand and cover up the I column over here, right? So cover this. Now, what you are going to do is a cross this way and this way, okay? So from left to right, top to down, okay? So go like this, like this. So you will have A2B3 minus B3A2, B2A3. B3, sorry. It's weird looking at a board at an angle, by the way. You must have heard teachers use this excuse all the time when they screw something up on the board. B2A3, there you go. Right. A2, B3 minus B2, A3, all right? And then you're gonna move to J. So now you put your hand and cover up the J column and then do the same thing. So now you have A1, B3 minus B1. So you're gonna do this. Minus B1, A3. Yes, okay. Makes sense. All right. Again, you move on to the last one. You cover this up and do a cross with these 4. All right. So now there's another reason why you see it's called a cross product. There's a lot of crosses going on, right? So the rule is you cover up the component that you're trying to fill in and trying to solve, and then the other do sort of a cross multiplication and subtraction, right? So you do this, right? So what did I have? I have A1, B2 minus B1, A2, okay? And the last annoying thing, if that is not enough, the last annoying thing is here, it alternates in sign. So it's plus, minus, plus. In fact, this is the part where most students miss the most. So I'm going to put it in red. Okay, so it alternates with plus, minus, plus, like that, right? So let's see if it's actually the same result, right? So if you look at C1, it's A2, B3 minus B2, B2, A3, same thing. Yeah, so you see it matches. This is A3, B1. Now A3, B1 is here, but it's minus, minus means this So this minus is going to flip these two essentially. So you see it's A3B1, it's here, subtract A1B3, all right? So that's correct as well. And C3 is A1B2 minus A2B1 minus A2B1, okay? Obviously you can retabulate this back into yeah, you can do this, right? And into a column vector if you like, but you can just call it a day over here because that's a lot of work, right? So you can just call it a day in the component form as well. That's fine, all right? Okay, so that's vector cross product. You know the geometric way and the algebraic way of doing it. I'll give you, let's do a quick example and we'll see why on earth are we even learning this? What is it going to do for us? And how is this such an obscure thing has an application in physics, okay? But let's just understand the math, right? We'll just understand the math first. So let's say I'm going to take A is 1, 2, 3, B is 1, -1, and -2, all right? Just make some minus negative numbers just to throw it into the mix, right? So, okay, so what's A cross B? Okay, so this is what I usually do. I will write this, and then I'll copy this as 1, 2, 3, all right? 1 -1 -2, okay? Then instead of writing IJK, I'll show you what I do. I immediately write this, and I put parentheses and minus signs here. So I know it's going to be positive something I minus something j and positive something k, right? So essentially, yeah, actually, I'll just do this first. And then I'll do the same thing. So like I said, because I usually like column better, it's up to you, right? I don't know what your personal preference in life is, but mine is writing in column. It looks easier to visually, at least. So yeah, so I know it's plus minus plus, right? So it's basically plus minus plus that way. Okay, so covering this up, I get -2. Should I show you the fast way first or slow way first? I'll show you the fast way, right? So after some experience, this is what you want to aspire to. It's shameless. Anyway, so if I cover this up, so do 2 times this, right? So it's -4 minus, so it's always this minus this, okay? So covering this up just to show you, minus this times this, so it's minus -3. And then cover up the j like this. So I get 1 times -2, so it's -2. And 1 times 3, so -3. And cover this up, so I have -1 minus 1 times 2, it's 2. Okay, and then I will do the math here. It's my +3, right? So it's -1. And here I have -5, but then +5 and -3. Okay, so if it asks you, say, hey, find C, if C is A cross B, then I'm going to say, hey, this is C. Or if the question doesn't have C, it just says find A cross B, then you're going to give the answer in whatever the variables the question is giving. Okay, right? So sort of that's with some practice, this is sort of where you'll do it. Just to be clear, just for completeness of the video, I'll do it wrong way. I'll do it slowly, right? So cover up I, so it's 2 times -2 minus -1 times 3. Cover up j, so it's 1 times -2 minus 1 times 3. And cover up k, so you have 1 times -1 minus 1 times 2, right? So then you have plus -4 plus, did I do a mistake? Did I made a mistake before? No, it's the same thing, right? I think, yeah. and -2, -3, and plus -1, -3. Right. I hope I didn't make a mistake. Or there we go. Yeah. Hopefully I had the same thing. Someone's gonna rewind and tell me I made a mistake or somewhere, but hopefully I didn't. We'll see. All right. So something like this. Okay. Yeah. So you can double check with that. We can. Does it follow this sort of rule where is this guy really perpendicular to both of these? Now it's hard to sort of draw it. You can't. I can try with drawing 3D, but it's not going to look good, right? So 1, 2, 3. So that's 1 unit this way, 2 units this way, 1, 2, 3, 3 units this way. So you draw a parallel to the y. So 1 unit this way, right? 1 unit in the x, 2 units to the y, and you want sort of parallel to the z. You want to go 3 units. So this is the a vector. I can try my best. It's not going to look good, just a warning. And 1 minus 1. Okay, so 1 minus 1 in the y. So here's -1, right? So this is parallel to y. This is parallel to x, right? So this is 1 in x and -1 in y. And it's going to go -2. So 1, 2. So this is parallel to z in there. So this is the b vector. And finally, let's see the result of the cross product of A cross B. It should point somewhere this way. So swipe your hand from A to B and see where your thumb goes. So it should start that way. Let's see. So -1. All right. So need to extend the x-axis here. -1, 5 units. 1, 2, 3, 4, 5. All right. So -1 was here. 1, 2, 3, 4, 5. It's here. And -3. So I need to go down. 1, 2, 3. So origin to here. Does it look perpendicular to both A and B? Yeah, everything's lying on the plane. It's super confusing, right? So don't. My advice is I almost didn't want to do this. It's not going to look good. But let's try to do a simple one. If I do a I cross J, okay? So I is really 1, 0, 0, right? J is 0, 1, 0, right? It's I is the little unit vector that goes in the x direction. J is the little unit vector goes in there. K is the unit vector goes in there. All right. So can I repeat this thing? So let's see what happens. All right. So that's I, that's J. All right. So we'll have plus, minus, plus. And now I'm going to cover this up. So 0 times 0 times 0 minus 1 times 0. Cover up J. It's 1 times 0 minus 0 times 0. Cover up K. I have 1 times 1 minus 0 times 0. And my answer is 0, 0, 1. What's that? That's K. Right? Now, can you see K is perpendicular to both I and J, right? And also, if you swipe your hand from I to J, you precisely get K, right? Try that, right? It's better if you have like actual 3D. Try to take 3 pens and stick them together like this, and call one of them, color code your pens, and yeah, so you can use a finger like this, what my friend called a 3D loser sign. Just kidding. But yeah, you can put it like this and call one XYZ, so you can see if you cross one to the other, you get the third. All right, so play with it, be creative, whatever you like, whatever way that works for you, that's fine. But yeah, so I'll leave it as an exercise to you, what you should expect. So give this quite a few a try. What you should expect is J cross K. What is it? Sorry, J cross I. What is it? So I cross J is this. So you want to check this should be minus K. So the answer, if my rule was correct, if you flip this around, you should get 0, 0, minus 1 for this. All right. But yeah, so the exercise, let me summarize. first do I cross j. So check this is true. Then swap this around. Okay. Right. So this is the first two. And then try I cross k. You should get minus k. I've done these 6 exercises before. So k cross I should be j. And what's left? ij, ik, jk. J cross k should give you I, and k cross j should give you minus I, right? So these are easy ones to quickly try. And you can try another one in the textbook as well. Try if A is equals to 1.2, 1.2, 0, 1.2, and B is equals to 150, 0, 0, and you should get A cross B will give you 0, 180, 0. Okay, so A cross B. Yep. So let's call that exercise 7. All right, so you can give these all a try and yeah, see how it goes.